Today I'm going to teach you how to write rational numbers as decimals. So we're changing from fraction form to decimals here. To write rational numbers as decimals, you need to perform long division. Just a reminder that the steps to long division go in this order. First we divide, multiply, subtract, bring down, and then we repeat that process until we're complete. So here I have some examples of writing rational numbers as decimals. In this case, they turned 5/8 into a division problem. Notice that we are adding a decimal and they chose to add 3 zeros. You can start one at a time and keep adding if you want. But we know that's necessary because we know 5/8 is less than 1. So we know our answer is going to be below 1 and we need to add some zeros there. So they went through the process. They divided 8 into 50, subtracted, brought down, and repeated. And 5/8 as a decimal is 0.625. 2 1/4 as a decimal. They ignored the whole number of the 2 for the time being and just changed our division problem as 1.00 divided by 4. After they went through the long division, they wound up with 0.25. And in the end, they brought that whole number back and put it in front of the decimal and made it 2.25. It is possible to have done it this way, where you could have done 2 1/4. You could have turned it into the mixed number, where they did 9/4, and then you would have had 9.00 divided by 4. You got to bring that decimal up. 4 goes into 9 2 times. That's 8. Bring down the 1, subtract, bring down the 0. 4 goes into 10 2 times. 8, subtract. We have 2 and 0, and 4 goes into 25 times. So you wind up with the same answer, but it's just a little less steps if you bring that whole number in at the very end and put it in front of the decimal. Now it's time to practice a couple of these problems. We can do number 1 together. 3/25. So I'm going to set up long division. 3.00. I'll add 3 just for safety. We might not need them all. Divided by 25. So straight away, I'm going to bring up my decimal right above where it is. 25 can't go into 3. It goes in 0 times. So I put that 0 there. Now 25 can go into 30 one time. So 1 times 25, I subtract, it's 5. And then I bring down my next 0. 25 goes into 50 2 times. 25 times 2 is 50. At this point, I've wound up with 0, and I have nothing left to bring down but more zeros, so I am finished. So 3/25 is equal to 12/100 or 0.12. Let's do number 2 now. I have 17/16, so I'm going to put 17.000 divided by 16. This is a little different. Again, don't want to skip that. Bring my decimal up. Make sure it's in the right place. 16 doesn't go into 1, but it does go into 17 one time. So I'm going to multiply 16 by 1 and get 17. I subtract. Now I bring down a 0. 16 does not go into 10, so it's very important I put a 0 up there to represent that. 16 times 0 is 0. Subtract, bring down the next 0. 16 does go into 100 6 times. So 6 times 16, I'm going to do that math over here just to make sure I'm correct. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 96. So 96 there. 100 minus 96 is 4. I bring down a 0. 16 goes into 40 now 2 times. Just going to erase this so it's out of the way. And now 16 times 2 is 32. I subtract. I have 8. I'm not finished yet, so it's definitely okay to add another 0 here. Okay, so 16 can go into 80 5 times, and 16 times 5 is 80. So now we're at 0, and my answer is 1.0625. I'm going to do one more, number 3 here, 2 1/8. I'm going to ignore that 2 for the time being and save it for the end. It's a whole number, so I know it'll go in front of my decimal. Now I'm going to do 1.000 divided by 8. Bring my decimal straight up. 8 doesn't go into 1, so that's why I put the 0 there, but 8 does go into 10 one time. 8. 10 minus 8 is 2. Bring down the next 0. 8 goes into 20 2 times. That's 16. 20 minus 16 is 4. We're going to write over number 5. And 8 goes into 40 5 times. 8 times 5 is 40. I'm left with 0 with no other digits to bring down. So I'm finished. This same process applies anytime you are trying to turn a fraction into a decimal. Sometimes fractions will not end if you keep dividing. They just seem, the same thing just seems to keep repeating. 7/9 is a great example of that. 7/9, so they set it up as a long division. 7 divided by 9. So 9 goes into 70 7 times, which 9 times 7 is 63. It keeps becoming 70, and they keep bringing a 0 down. You notice a pattern continuing to happen. So 7/9 is 0.77, and that always goes on. You can mark this by writing 0.7, and because the 7 is the digit that is repeating, you can just put a line right over that 7. That is a clue, that's a hint or the notation to tell us that that 7 will go on forever. So let's try this with 6/11 and see what happens. 6.000 divided by 11. Bring my decimal up, add my 0 in the ones place. So 11 can go into 65 times. 5 times 11 is 55. Subtract, bring down. Now I have 50. 11 can go into 54 times. So 11 times 4 is 40. 44, excuse me. And 50 minus 44 is 6. Bring down that 0. Ooh, I'm back at 60. 11 goes to 65 times. 11 times 55. 11 times 5 is 55. So I see a pattern. I'm going to be switching off when I subtract between a 5 and a 4. It's going to keep happening. So I can stop because I know that my 0.54 is going to keep repeating. Since it's both numbers that repeats, I put my line over both numbers. Number 8, you can plug into a calculator and you'll see that pattern repeating itself. Comparing rational numbers written as decimals. This got a little cut off, but it's really important anytime you're dealing with a rational number. If you want to compare it, the best way to do it is to convert it to the decimal form using the long division. That's what got cut off. No big deal. So 9/8 and 10/9. 9/8 got converted with long division to 1.125 and 10/9 to 1.111 repeating. So all you're going to do now to compare is we're going to look at the first digit and we move left. They both have a 1 here, so we have to move on. So we go to the right. We go to the right. Again, it's both a 1, so we can't tell yet. But now we go to the right another digit. Here we have a 2, and we know because this is repeating, this would be a 1. 2 is larger than 1, so we know 1.25 is greater than 1.1 repeating. And you could put it back in fraction form as 9/8 is greater than 10/9 repeating.